Gonna work all right. Whoop, that's misspelled. Well, hey, it's Sven with another Code Hangout working on SudokuPad. Welcome, welcome. Code Hangout number 92. Let's work on a simpler Pencilmark checker. All right. We're actually going to do two things. We're going to work on a simpler Pencilmark checker. So basically, we want, I need a different example puzzle, but basically you want something that basically does this functionality, but only for rows, columns, and boxes. And the reason for that is there's certain puzzles where it makes it kind of easy because it highlights things related to cages, and in fact I just solved a puzzle from today's daily Sudoku. In fact, that was a good one. No, not from today's daily, from the puzzle archive. Let me see if there's still anywhere within scrolling distance. Yeah, because it's an irregular one. So, does not have a CTC link for SudokuPad. And that's exactly the sort of thing where the current Pencilmark checker, for example, you see it highlights like the disjoint cages and things like that. It knows that there's a region here, and this is a disjoint region, so this cell can see these cells, and it doesn't do it for everything. Like, it doesn't do it for thermos and for arrows, even though, for example, this cell can. Yeah, I guess it's not the same because it sees these two cells, but in the way that it cannot be there. Not that we know what's here. Well, I guess it's the same thing, right? So a cell in a bulb technically sees the ones on the arrows and so on and so forth. But Mark just suggested, because some people have a problem with the solution being embedded in the puzzles. And that's been kind of a back and forth, and I don't agree with that there's such a thing as cheating in a single player game. People can do what they want, what's fun for them, But he suggested that maybe we can replace it with a hash code, and that might actually not be, A, it might not be difficult, and B, it might be kind of a quick, simple thing we can implement. Let's get that solution. Oh, wait, yeah, we can have a script for this, right? So we can just go to localhost. Nope, we go to localhost, and then we just solve it. Boop. All right. Now, I'd like to see if I can make a version of this where instead of having the full solution, we just have, and you know what? This is the sort of thing I should almost have like a subtitle for the stream so people know what I'm working on. It's something maybe I'll think about for the next stream. Kind of a lower third type of situation, Come on. Yep, there we go. So the idea now is that instead of checking against the solution, which is obviously stored in the puzzle, current puzzle.solution. So if we just have a hash of this. So let's have a look where this is being used. This might be used a couple places. Yeah, it might not even be, it won't be even referenced this way. It will probably be, oh, I'm probably searching in the wrong place. Yep. And we'll do it this way. And so there's a couple of places where we're using it just to check if there's a solution. And this also makes me think that the puzzle internal should just be a raw data structure, but maybe should be an object, so we can modify things like these under the bonnet. So the puzzle itself, the puzzle data, is an object with a couple of properties and methods and stuff. Things like, get hash and check solution and whatnot, or has solution. So, we don't have to do an undefined check, and then we have to be backwards compatible to some weird property of the data structures. So, for example, there is this is solution blank here, for example. Puzzles decoder. So that's, oh, I got a crackling on my audio. The heck is going on here? Sorry about that. I swear there's some wires loose inside my microphone. Hey, Mark. Maybe provide that one too. The set of digits used. Yeah, it'll get complicated quickly. Let's do one thing at a time. Because then somebody will say, oh, knowing the digits used is actually a giveaway, because maybe the puzzle consists of having to determine which digits. But that's kind of the problem, right? People don't think beyond the immediate need, and they think it's an easy solution. They don't consider the actual caveats. Let's just do a quick rough substitution. So, yeah, there's a whole bunch of things here we're checking. Solution. So I'm guessing the main place we want to look at is in the checker, the solution check, right? So we have, the thing is, yeah, maybe it's not that easy after all, because it does partial checks, right? And a hash would not support partial checks. Unless we almost hash each individual cell. Is that a possibility? Don't think so, eh? Because basically, okay, yeah, I don't think it's as easy. As usual, it's not as easy as what people think. Let's make a couple of notes, right? So, current use of solution data. There's a bunch of different ones, right? We are using it to check if puzzle is solved correctly. So that's step one, right? But we're also using it to discover valid digits for puzzle. But there's also other things we're using it for, right? I'm pretty sure we're doing a per cell check. We're, for example, using it to validate features. So, for example, we can use the solution to see if a killer cage is a what do you call them? Say what you see or whatever, cage, right? So this has to be kind of an optional thing. The problem is right now we don't have the internal infrastructure to easily disable some of these features. We'd almost have to kind of have a separate field here, right? So instead of checking for the solution, if checks.solution, yeah. So we'd almost have to have a separate check here that if solution exists. Or sorry, it's kind of like a that it basically has is a separate piece of data. Solution doesn't exist on that particular puzzle. All the other checks treat the puzzle as if solution doesn't exist, and then we have a separate one, right? So let's do a quick. Oh, let's ask ChatGPT about that, right? Yeah, no, just start a new chat. Let's see if it's online right now. Came back earlier today. All right. So I don't have to write the boilerplate myself. So I think we can just use crypto, right? Oh, it's just going to implement it? Ugh. Oh, no. At least now we can stop it from jabbering. What is the crypto API in the browser? Have I... Subtle. I am actually not familiar with that. Whoops. Didn't I use it already for something? Did I not? Sudoku tools. No. I mean, I guess we could implement a simple MD5. Don't I have MD5 already here somewhere? I'm pretty sure I have an MD5 implementation. Yeah. Okay, let's just use that one since we already have it in the code base. So, I am not where I was. I'm not where I once was. All right, so I'll put the solution. And I don't know why that's gotten closed. Sorry about the squeaking. I don't know. There's something in my monitor stand that's squeaking every time I bump into the desk, and it's all very wobbly, and I need to do something about it. It's driving me crazy. All right, here we go. That, what? This puzzle, oh, yeah, okay. So MD5 digest just blows up if there's, if you're passing in undefined. That's interesting. Kind of annoying as well. All right, so we have a digest here. And we should be able to generate, so if we get it, the P81 data, right? This should always be the same as the puzzler, as the solution, right? Ideally, I could. Let me look at one of Bremster's puzzle problems. Because those implement gaps in the puzzle solutions. Whoops. So it'll be good, a good test case. My mic is loud. Why don't you tell me in chat so I can hear about it? I must have messed around with it the other day. How is this? Hey, how is this? Is this better? Hello. One sec, I don't see my mic on the mixer here. Hello, 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 hello. Hello, 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 hello. Hello? How is this? Is this better? That's probably what's the crackling I heard earlier. The gain was all the way up. How's this, Mark? Why don't you talk to me in the chat where I can see it? I have to make the rounds. All right. So I'm gonna go back a couple because you know, in case people haven't played them yet. But Bremster has the Sudoku problem series going on. So let's go to number 75, for example, right? And in this problem series, basically, he has puzzles that you only need to fill in like one digit or a couple of digits. So let's see if... And usually these are done using the partial solution method, basically. Oh. So for example, here the solution would look like this, right? I'm guessing the solution is a 5 in the center, right? So if I do this, yeah, and let's just align these here. So they align, and let's just do this. And we're just going to do something like, let's do something like, so. And let's do that. And we'll just do this as well. And now we'll do the same thing with the digest. And in theory, they should be the same, right? Yeah, sorry about that. Is the volume good? It still seems to be peaking pretty high. Might have to turn down the volume on the mic a little bit. It's too loud. So, clear that. 5. False, true, true. So for a full check, it'll do the thing. Now I changed it to do a per cell check since we were iterating through the cells anyways. And I think this was designed to help. There's something in my hood. A leaf. Some plant deposited a leaf in my hood. When did that get there? All right. Now, I don't know if I did this simply so I didn't have to iterate over this multiple times. I think I partially did this so it ignores extra cells outside the square. And that's kind of part of the problem, is that these kind of features will not be possible with a checksum-based solution, right? The only thing I could do is... But no, because I wouldn't know if the original checksum was built from a solution that ignores these or not, you know? Or I guess what you could do in the checksum, you could just strip out all the blanks. So it basically ignores these. And I don't even know if it differentiates between dots and question marks at the moment. Yeah, because I think dots means it expects a blank, while question mark... No, sorry, dot means blank or anything, and question mark means specifically a digit cannot be left blank, I believe. Like any digit. If expected is question mark or found equals expected return. If expected is question mark. So if it's question mark, anything goes. If found is blank and expected is blank, then we're good. If found is not blank and expected is blank, then it'll fail. Okay, so question mark allows anything through. So that's kind of a problem. Unless we do like a more complex encoding. Unless the I'm just trying to think. If we convert all dots in the encoded or in the actual data, like we could remove dots, which are the blanks. The problem is question mark in the expectation would mean those aren't being removed, right? So we'd have to actually encode which cells are allowed separately. It gets very messy very, very quickly. So this definitely would not work for complex puzzles, right? Or at least it wouldn't support these kind of more complex check patterns. And it's always interesting that the people who ask for this work to be done don't have the time to stick around and check out the stream when I actually do the work. But that's exactly the thing. Right now I'm guessing on what the intentions are, and I'm getting tired of guessing because people just yell at me all the time because I'm guessing wrong. And people don't realize what they're asking for. And if I give them exactly what they're asking for, they'll complain about that anyway. So then sometimes I don't really feel like giving them what they're asking for anymore. I mean, like I said, this would be a completely separate check, basically, and it would just check the full solution, and it would just not support fancy gap things. But then, you know, people will immediately start complaining about it because they'll immediately want that, or are surprised that it doesn't magically work, you know? Like, there's no way of... I don't think there's any way of having an encoding where, you know, any digit will decode or encode to the same value without knowing what that value is, right? It's just not possible. And I bet you the same person, if I just zip the solution data up, they'd probably be happy because they don't understand how any of this stuff works, you know? If somebody who wants to cheat, you know? I mean, like, if somebody wants to cheat, they run it through a solver. I mean, that's the thing, right? That's what people seem to forget. Even with I mean, you could brute force it against the checksum and all this stuff. Like, if somebody wants to cheat, they're fucking cheat. I mean, it's a Sudoku, right? There's only so many different digits that can get in there. I mean, the other thing that one could do is take a leaf out of like a page of the book of the way Logic Masters Germany does it, right? So they have like one row or something. So we don't necessarily need all the digits, right? It's supposed to be just a rough check. I mean, the easiest would be to extract a bitmap pattern of the actual digits that are to be checked. Ah, Jesus Christ, it's so squeaky. And just trying to think what a good, I mean, I guess it could just be a hex encoding. All right, let me do that quickly here. So let's say we'll do this on the solution here, or let's do it on the P81 data, right? So we'll do something like this. We'll do... We'll replace... We'll replace... Because, like, I'm already thinking, like, what if in the future I want to allow ladders in the solution and so on? So I'm guessing in the moment it would just work for these specific symbols, and in the future we'd have to update them. Oh, the squeaking is driving me bonkers. So if we replace all of these with zeros, for example, right? Ah, no. Ideally we want to do this in one pass, right? So if we split it up, then we map it, right? And then if the digit equals these, we return 0, else we return a 1. Something like that. And let's just run that quickly. And then we want to rejoin these. Right? Then we want to split these into sets of... can we do a... We can... can we do a split... like split them into sets of 8. I hate the frick. All right. And then we can, we'll take these guys, we'll map them. And do that, I guess. And then we want to map them or turn them back to a string. Base 16. We want to dot add start to 0, I guess. And then dot join with blanks. No, you don't need to escape inside the square brackets. And somehow we ended up with a gap. How did we end up with a gap? Oh, yeah, no, that's fine. That's just because I'm outputting 2 strings, right? Yeah, and there's an 8 in here. So that would be the hex represent. The annoying thing is it's quite long, right? And I guess I could turn it into base 24 or something. If it supports that. And if I do that with something like this. Does 2 string support bases of above? Based above base 16? I don't actually know if it does. Do string, return value, arguments, yada yada yada. Arguments, object return. We need number.toString. Radix 36. Okay, so it should go up to 36. 36 is how many sets of 8 digits? I don't actually know. Because I don't know if I need to pad it by 2 then. Base 36 means how many sets of 8? Base 16 is nice because it's 2. So base 32 might make sense, right? So let's do this. Right? So that should give us sets of 16 digits. Where's the 0 though at the end? One, two. 1 second, I'm missing a 0 at the end here. We've got all ones here. Oh, because it doesn't subdivide evenly into 16. Yeah, okay, so the more... we need to start padding it. Oof, this is annoying. 81. So if I say 81 divided by 8, I get that. If I do 16, I get that. And if I do math.ceil, I get that. So if I can do something like so let p81 bin equals this. I'm gonna comment this out for a sec. So this is basically just 81. This is just a bitmap. Now we're gonna pad it, right? So we're gonna do this pad start p81 bin dot length divided by 16 math ceiling, so we round up, right? And that should with zeros. Will that give us the length of these things? I don't see it. 81, 81. No, 81 is not. 81 divided by 16. 81 divided by 16 is 6 times 16. It's actually shorter. Times 16. And now we're at 96. Okay. Does it matter if it doesn't match what we have afterwards? Yeah, because the bitmap is only telling us the cells we care about. It doesn't tell us about cells we don't care about, right? So it just tells us of the original data, only use the ones where we have a 1 in this set, right? So do I even need to go through binary here? Ah, okay, so I can do 32 as well. If I want to go base 32. Right? Const new radix 32. So we'll just do this. And then we'll take that and we'll split it. Isn't there an easier way of splitting a string into equal lengths? I mean, I know I can build a regex out of it and all that stuff, but it feels a little annoying. Ugh. Yeah, like I can do this, you know? I'm just going to use the regex for now. Although, is this something we're going to do? Let's not optimize things just now. So we'll take this one. So we now have that. So now we want to match it against something like this. Right? Yeah, double commas it doesn't like. Okay, so now these are split by sets of 32. I'm going to take this whole thing, and then we're going to map them. So we'll... Why am I parsing them into binaries here first? Oh, because they are binary. All right. Parsed into space 2. No, wait. They already base 2. Oh, because we're turning them into a number, right? Okay. Then we're turning them into the new radix space. And then we're padding them. And we're padding them by the rate. I'm trying to think. How many digits? No, these are by definition will only ever become 1 digit. Right? What? Two-string radix. Parse int set base 2. Two-string radix. And we're missing a comma here. Where do my commas go out to? All right. How are things going on Twitch? Looks like Twitch is working. All right, so we're basically getting these. Okay, no, because it doesn't have leading zeros, right? So we need to add the leading zeros after all. Shouldn't... I'm a bit confused, right? Shouldn't this, a 32-digit binary number, become a single digit in a base 32 number? Like, isn't that how this is supposed to work? I'm kind of confusing myself here, right? Let me make this a bit bigger so this is visible in the stream. It's probably too small. So we're creating these big numbers here, 32-bit numbers, right? Shouldn't be a problem. But in base 32, they should be 1 digit, not multiple digits, right? It doesn't make any sense. A 16-bit number becomes 1 hex digit, not 2 hex digits. So something isn't going properly here. So integer range to specify the base to use for representing the number value defaults to 10. Is it because what parse int outputs? So if I say to string 2, it becomes all ones. If I say to string base 8, base 10, okay, base 16, base 24, base 32. Base 32. Isn't base 32 32 bits? Yeah, 2 to the power of 32. 16. Ah, wait a second. No, well, how did I end up with 8 hex digits? That doesn't make any sense. Each of these is 8 bytes. Something went wrong here. All right, so base 16 is 4 bits, not 2 bytes. Base 16. Base 16 is 4. Oh, you're right. Oh, I'm an idiot. Okay. So we need. So 32 is. Base 16 is 4 bits. Wait, but I don't care, right? All I care is that I get one. Oh yeah. Okay. I see what you're saying. So base 16 would give me 4 bits gets me 1 base 16 character. 8 bits will get me 1 base 32 character. No, that doesn't make any sense. Oh, I'm getting myself confused. 2 to the power 4 is 16. 2 to the power of... Yeah, but I want to just use numbers right now. I don't want to do special encoding, and toString doesn't support that. Because base 64 then, because I can't use numbers, I need to actually... like, encoding this string doesn't actually... You know, in base 64 is actually super big because you're encoding a string. You're not encoding numbers, right? I'm just getting myself confused. This is base 10, right? So toString base 2, base 4, base 4, base 8. So that's octal. Base 10, base 16. That's hexadecimal. Base 32. Okay. So what I want to do is actually, I want to do parse int 111 to string 32. 8. So if I make this 16, it's FF. If I double it, I'm only adding 2 bits of thing. So if I double it, it just means I'm getting 1, 2, 3, 4. So it means I have to split it into 10. Yeah, it's not worth the time I'm spending on it. So instead of doing all this fancy schmancy stuff, I'm going to go back down to... So 8 bits is 2 hex digits. So what can I get? How many do I need to get 1 digit? How many bits can I get into base 32 digit? 1, 2, 3, 4. But I think that's the same for 31, 16, 24, 17, 24, 6, 7, 8, 9, 30, 31, 32, 33, 30. So 32 gets us a V. 33, 4, 5. My God, I feel like I've forgotten all of this. Okay, so 32 gets us 5 digits in base 32. So if we split it by 5, 5, and then go by base 32, radix. So I think radix is 5, and then 5 base equals 32. So if we do this, right? So this should get split it by 5, which it's not doing. Because we need this here. So that should get us sets of 5. Then that should get us these numbers, and that should convert to a single character in radix, yada yada. And then at the end we join it. I should have just kept it simple and worried about the encoding later. It doesn't support base 64, it only goes up to 36. I'm talking about toString and parseInt. They only go up to base 36, where they internally deal with numbers. Anyway, it doesn't matter. It doesn't matter. There's going to be a black box, and the black box we can build off screen. So we get a string, right? So we're going to do so we'll do a function p81 get p81 map p81, and it just does that, and it doesn't actually care about it being 81, obviously. So we'll split. So we're starting with p81 up here, and we're splitting it. Then we're mapping it to zeros and ones. Then we're joining it. Then we're padding it. Then we're matching it, and then we're mapping it. All right, so that's our map, right? And then we'll want to do the reverse. So we'll do the same thing again. We'll split it. We map it to parseInt and base, I'm guessing. Right. Then we're converting it to base 2. Then we're padding it by radix with zeros. So they should all be 5. Now the annoying thing is here is that we're getting a padding at the beginning now instead of at the end. So 1 second, let me grab one of these. I think this one. See what it looks like. Oh, this is squeaking. So that's parseInt set base 2. We don't want to do that. We want to look at that. No, okay, we have a 001 at the front. Is it because I'm padding the start? I should pad the end. Yeah, exactly. So the problem is I'm padding the start. I'm going to pad the end. And here we'll also pad the end. Now for the individual characters, we need to pad the start. So we'll start with this. And then we end up with this. That's wrong. So we have the pad end. Pad end. So if I take this and finish the job here, basically. So what did we do after the match? We did this. We get a G here and a 0 there. Okay, how are these different? I changed this to pad end. So we've got this. That's the same as that. Then we're padding the end. Length. Oh. Do I know the length here? Yes, it's the same length. Okay. Oh, yeah. We don't want to start with bin. We start with P81. Okay. All right. And then at the end, my God, what a mess. I always get myself into these messes with simple things. So we now want to... I think we're ready to decode now, right? Yes, double commas again. All right, and now we can do a decode. So this is going to be the map. We'll split it. We'll parse it. We'll convert it to binary strings. We'll pad them. Right, we need to pad them. Then we'll join them. No, wait, do we process them here? No, we'll join them and that's it, right? And then we have our map. And this map should match what we started with. Minus, you know, the length. Because we don't... Do we want to encode the length into it? If we encode the length into it, it would be kind of a complete format. But then we might as well create some sort of JSON and just... Let's just use this for now. And it'll have an optional length argument. So if I do this and don't pass anything in, what do I get? And if I pass something in like p81.length, yeah. And we won't call it p81, we'll just call it solution map. And I did not loop the music. All right, come on, guys. Get on it. All right. So that gets us the map, and hopefully it's correct with other maps. We'll verify that. All right, it looks like it would be. Okay. So we now can have a solution map. Oh man. It's a little messy, but we have a solution map. We can have a digest. So let's do something like const height sol. And we're gonna basically returning an object that looks like something like, we'll just concatenate the two with a pipe symbol or something. So we'll just do we'll do this. Or let's get fancy. And then we want to do our digest like that. So we have our P81. Well, let's output this a little bit more. Structured. Right, so this would be our encoded hidden solution. Man, it's so annoying that just the bitmap is half the size of the entire solution. So annoying. Ah, no, sorry, that's the hash, right? Okay, if we look at something like this. Okay. And now to verify it, we basically need to extract the right digits from P80 from our P81 thingamajig, right? So we want to do a thing like check against hidden so. And here we'll just pass in sol and P81 data. And I call it P81, even if it's not 81 digits. It works for any size. It's just how my brain works. And we'll pass in. Okay, so we'll do let hidden sol. P81. All right. Well, which doesn't do anything right now. Let's get rid of that. It just makes it so long. Very, very clumsy. And let's call this hsol just to differentiate. Okay. So then we'll split this one. Map, digest, 5. Split that. So now we have map 25. And now we can decode map. So we can sol map decode like this. So that's our decoded map. we have our P81. Now, now we want to decode that to the length of the P81, the puzzle. All right. So that's our map. So in this case, it means look at all digits. In this case, it means look at just that one, right? And now we basically want to, what do we want to do? We want to set all digits to empty. So we need to decide now how we're going to encode what we're generating the digest of. Yeah, so we need to actually take the solution into consideration when we're building the digest. So it's not just this, it's the solution mapped through, the solution kind of, all right, so we'll first do sol map. And it's basically just this, right? And we can output that here. And that's just a bitmap with ones and zeros, right? Sol map is here as an array. Actually, we'll join. Yeah, we will join that. And then here we'll actually do sol map sol, and we'll start with that, like that. So we have a sol map here, and then we get that here in the end as well. But now we're generating the digest only on the digits that the sol map includes, right? So sol map encode, sol map decode. And then here we'll do a function that takes, we'll get, we'll call it mapped sol map digest, which takes a solution and a map, right? And then generates a digest only of the digits that we actually care about. So we actually do a sol.split.reduce. And we'll just have a accumulator current IDX log at car IDX, and we want to run that here on sol and map, like that. And this is basically going to strip out any digits that have zeros in the mapping. So what do we get? We start with undefined. Yeah, okay, we're just outputting it, right? And these are the indexes, and these are the values. And we can also now pass in map IDX, right? And then if, yeah, okay. So basically here, instead of logging this, we're now gonna say we're returning accumulator plus, and now it depends on if this is a 1, then that, else an empty digit. I think that's it. So sol map digest. Yeah, so that in this case would just return a 5, and in this case it would return. We're operating on the solution. Let's test it also on the P81 data. Sol map digest with a dot at the end. Wait, sol map digest. Yeah. If we're gonna do it on this, we just want to do this actually. This is just a test because the map of P81 data is different because we're, the solution has them all filled in. So here we're missing one digit in the end. And this would be the digest data. Yeah. Okay. So map digest. Now this doesn't actually get us the digest, so we'll do the digest here. Hey guys. MD5 digest of this. And for comparison, we want to output the regular digest of the P81 data here. Just to see how that differs. So now we have the regular digest here and the mapped digest here. Now it doesn't actually save us anything, right? But it's all about the check on the other end. So we can exclude certain digits from the check. So we have the digest, we have the map digest. And now we got to do the same thing on here. So we want to do this. Sol map encode, sol map digest. Yeah, so we're doing the digest based on the map. So we pass in the map like that, right? So this is now the digest of the solution separated out by the mapping. Oh, my brain. Okay, and now we do the decode on the map, and now we can do a digest of the P81 data of the decoded map, right? Right. Like that, I think. So this is our decoded map. We have the MD5, and we have the MD5 of our P81 data according to the same map, which... And let's not call this... Well, it is an MD5, right? Sol map encode. Sol map encode. Solution map. So we're encoding the solution map. Ah, no, that's not what we want. No, sol map. Not the encoded, because the encoded is not a 0, 0, 1. It's not a binary string that we need, right? Let's do it this way and get rid of that. And then we'll do map sol here. And we'll do the digest there. And then here, yeah, we'll do the same. Well, let's get rid of that for a sec. And we get rid of that for a sec. So check hidden solution. So we have sol map. Yeah, let's forget about this one. We have sol map sol. Now we want the mapped solution like that. And I feel like I've overwritten a brace somewhere here. So we have sol map. We have map sol, and it just becomes the 5, right? And then that is what we're generating the digest for. So if I do something silly like an MD5 digest of a 5, and I hope it stringifies it, it should be the same. All right. Map sol sol. So it's the E4 D5. Yeah, so that's the right thing here. So decoded map. Now if we create if we run map sol on this here, but not on the solution, but on the P81 data, on the with the decoded map here. Right? Don't need 2 of these. Yeah. But if we put a 5 there, this comes out as a 5. And if we wrap this into a digest like this, that digest should finally match the digest we put in. So this, starting with E4 and D5, should match that. And it should also work on a almost full solution here. So we have an E1 here. And it's not. Now in this case it isn't matching because the solution actually doesn't have a gap there, right? So if we put a 1 there, it works. And this now matches that. Okay. So all right. So map sol map decode, sol map solution. At P81 mapped. That. And then we'll just have the digest of that. Like that. And that should tell us if we finally have a matching solution, true. And if I remove the 1, false. And in this case, if I do this, we get a true. And if I put something here, it's still a true. Now, in this case, that's actually not a valid solution. So maybe only the question marks should be excluded. I don't know. I don't even know. Maybe the map should only map out the question marks, not the full stops. And full stops represent empty cells, right? Not any value goes. So if I now put a 1 here, like this is true and this is false. And this is true. All right. I don't know exactly how many unnecessary steps I have all over the place. Probably a bunch. Let's just get rid of all the logging for a sec here. Right, and we can just return this. And that should be fairly flexible and or robust, right? Okay, so what do we have here? We start with a solution. So none of these are necessary, right? Right, we start with a solution. We have some puzzle data here. Right, we have a hidden solution now. And we can check the hidden solution against the puzzle data. And that's basically all we care about. So we have a solution, we have puzzle data, and it matches. And it doesn't match. And this way, doesn't match, and that matches. And it would be fairly tricky to reverse engineer the MD5 hash, right? Now, this only works on a full solution. I don't think I can hash it in any way where I can do a partial match. I don't think that's possible. Like, I don't think there's a way of, like, a holographic encoding is what you kind of needed, right? Where you would say, here's a bitmap of incoming data, and somehow that bitmap translates the hash into a hash of only those values, right? I don't think such a thing exists. Maybe I'll ask ChatGPT about it sometime. Okay, now the thing is, this isn't really directly applicable. I guess one thing we could do is we could have a separate process that adds like a hidden solution. So let's for example, let's as a quick test. Let's do this. I need to wrap this also into something. We really only need the check function and the do we need the encode? The hide solution function, right? So I'm guessing this should be a sort of simple class. Maybe I can put that in here. So, and I guess it needs to be underneath the checksum. Does it? I think so. So if I say hide solution, and we'll create a simple const hide sol right. Put this stuff in there. Is there an easy way? Just trying to think if there's an easy way of making these editable from the outside. Only if I do something like this. I mean, there's no point making it instantiable. Any other radixes, radii, and base. hs dot sol map. So we have encode, decode. We have map sol, hide solution, and check hidden sol. And I think this one we can just just shorten it. And these probably we can just call encode and encode, decode. Right, and then the rest are just kind of helpers. So if I refresh this now, oop, can access Heitzel before initialization. Oh? 548. Oh, HS. So hide so dot check should be a function. Yeah, okay. So now we can just do hide so dot Heitzel, which, you know, is pretty bad. And then check. That's a little better. I'm bad at naming things, all right. Okay, then we can get rid of all of this. Let's try it on the sparse solution as well. Okay. And now we could... I'm tempted to put it in the fpuzzles decoder, but I don't actually want that because it's not really a feature of fpuzzles data, right? It's just generic for anything. So what if we just do it here for a second? And we'll do something like... we'll do current puzzle dot hidden solution equals this. Right? And I think Heitzel does not need the length of the original puzzle data, right? It only cares about the solution itself. And then we can do something like this. All right. Let's just comment this out for a sec. Yay. And then we can do something like this. If checks.solution and dot hidden solution. And then we'll basically do a Heitzel check like this. And we're looking at the puzzle data. What do we have access to here? Puzzle, current puzzle. Ugh, I'm just going to do this. I'm not going to do this. Puzzletools.zip. This should be on. This should live on the puzzle itself, right? Since it doesn't actually use anything from I'll just put that down here. This, this uses nothing from the application. And then we can go here. Puzzle dot to P81. And I guess we'll just have to emit an error if it fails. Now, of course, cells. Oh, seriously. Yeah. Check true, true. Put a 1 there, false. Remove the 1, true. And here, true, true, true. Okay, so if we're failing the solution check here, this is the error we're getting, right? So let hidden sol check. Do that. And then if not, there's that push. Expected, incorrect, third part cell. Incorrect. Errors push expected. Found expected. Yeah, don't apply here. Part. So hidden solution. This isn't really applicable either. Error in solution check. I think that's all there is to it. So if I do this, it doesn't give me the errors. Ah, here it'll give me the errors, right? So it'll give me a bunch of errors. Incorrect, missing count, type, incorrect, expected 1 found error. Okay. Here, if I put a 1 here and then force a check, we'll get error in cell. So these are cell errors. Obviously, we wouldn't know which cell has the error. So that's the solution check. Okay. Now, if we delete the solution then, so now we have a situation where the regular solution check won't be able to fail anymore. So these are, yeah, some uncount cage errors, and these are virtual cages, right? Or is that the region error? Expected 9, found 8. Yeah, that's the number of cells in the... Ah, okay, so these are for the box, row, and row, column, and boxes, right? Because they act as cages. Okay, but we also now get... wait. Do we not get the hidden solution? Check failure. Excuse me. So after it's run through this once, it should have removed the solution and inserted the hidden solution. Current puzzle solution undefined. Hidden solution is this. So hidden solution sticks around. So if I run a check now, we have a hidden solution, and it somehow doesn't hit the hidden solution check. Why is that? Cages, Pencilmark, cancel on solution. If checks.solution and current puzzle.hidden solution. And we probably want to run this earlier. Like this. If I run a check now, I'm not getting the error here. Why? Hidden solution, current puzzle. Hidden checks, that's the current puzzle, hidden solution. What the heck is going on here? We should be hitting this line for sure. Don't see why we're not. Checks.solution is undefined. Ah, okay, well, yeah. But if we press this, checks.solution should not be undefined. It's still undefined. What? Wait. Checks.solution. Checks. Is solution being translated to something else? Checks. The frick? If checks.solution for each checks feature equals true. Oh. Okay, so it avoids checking if there's a, yeah. So either we do a hidden solution check, or if not, and not hidden solution. All right, so if we do this, yeah, this is a pretty nasty code at the moment, and I definitely wouldn't want to put it in like that. And to be honest, the more important thing here would be the interface of how setters can add a hidden solution. So what I really want right now is how small of a change does the code require to stick this in here, and can I kind of make it like a switch? So can I basically leave some code in here at the moment and then come back later to kind of do it properly, right? So we can leave the code in utilities, no problem. This we don't need because we never actually changed that. Come on. All right. Now this, and wait, if delete, if not current solution and not current delete solution. Yeah, so that we can leave as well. That doesn't interfere with anything. If current solution, this is basically the switch that adds the hidden solution. In fact, we can just remove that for now. This is the solution check. So I think I would, yeah, you know what? Let's leave those in for a second and just comment them out. And we'll think of this as preliminary code. And this is also a safe check that doesn't affect. So now this is just the regular check without the hidden solution check, which just works as normal. Okay. And we can commit the code like this, and then we can kind of think of the interface of how the hidden solution would be added to the code, and then we'll just have to remove this later. So that, and this I think we can, yeah, I want to add that and change that. So these are all good. All right. So this is kind of a no op. But we'll do it, we'll make it a minor bump because it's not a patch. It just ain't. npm run. So dinner's being prepared, so I won't have time to really look deeply into the second item on our agenda. Where am I? Oh my god, the tabs are too small. Yeah. So this is a bit of a problem. So I think by kind of creating a second way of providing a different kind of solution that kind of sidesteps those problems, people who do that will need to know that it will screw with various features and properties of the puzzle. People always expect magic from me somehow, and they say, oh, it's obvious, why don't you just do the thing? And then they don't realize that the thing is not possible in a physical universe that follows the laws of physics. And I'm not sure what they expect from me. All right. Sadly, this means this is not going to be a new feature push today, but I didn't expect it to. But at least it showed me that it's not as easy as I thought, and it never is, and it's definitely never as easy as other people think. But sometimes I wonder if I'm a bit too pessimistic. Turns out I'm not. Hidden solution integration. All right, so we're gonna have a quick look at this. I think we have a similar problem, is that if we interfere with things too deeply, it screws up with things people don't realize are connected. So for example, let's actually, because the other thing is the pencil checker is a separate thing, I think. Mark solve digits, show scene cells. Is it not? I thought it was. Huh. Really? So because it's probably needed some deep internal integration. So check pencil marks. Yeah. People are always like, oh, just do the thing. Oh, it's so easy. Why don't you just do the thing? Check pencil marks. How is it even integrated? Oh, it's just styling, isn't it? So let's say if I put a 1 here and a 1 here, this is done purely via the style sheet, isn't it? So if I look at this guy, and it hits this style sheet because of its markings. It's actually... it's a lot worse than I thought. Oh, conflict. Maybe not. Maybe this. Conflict. I think I can presume this is a quoted string. Yeah, this is a really low-level integration. Pencilmark conflict includes error type. Okay, yeah. So the conflict is always marked, and if I disable that, all that happens is the flag in the style sheet isn't there, but the conflict is still there. So this is actually not nearly as easy as I thought I would be, and I don't even know where to start with that. So I would basically have to mark the different kinds of conflict with different labels somehow. Given that the system doesn't actually understand any of that, so that information isn't available. I don't know what kind of conflict there is, right? All it knows is that this digit can't be there. Now, I'm just trying to think. If I were to kind of implement it as a completely separate thing, like not deeply integrated with the checker, right? Run it similar to, let's say, show scene cells, or marked solved digits, or anything that any feature that needs to be triggered when you're changing the board state, right? So for example, show scene cells, which is what these yellow highlights are, it listens in to select, deselect, undo, and redo action. So any action that changes your selection, right? And with the pencil markings, we would have to, like, let me think. So the actions we would need to listen to. So selection and deselections don't change. So pencil mark, so corner mark, corner mark, center mark, digit, obviously, and then undo and redo, I believe. I don't think anything else. So we'd have to listen to these. The problem is a bit of a performance issue, right? Because, and in fact, the reason it's running here right now is because this has already been optimized to some degree, right? So for example, if I change a 1 here, I look at all the cells that the 1 sees and check if they need to be updated. Now here, since I'm already doing conflict checking, I don't have to do that because I'm already looking at all sorts of interactions. So I just roll it into this operation that already happens every time you do, you know, the checker runs basically. Yeah, this is gonna be trickier than I thought. Again, like, why did I think it wouldn't be? It's always more complicated than I think. So right now, man, and I've already put in so much work in the checker, like refactoring it yet again, you know? The problem is you don't want to run lots of different algorithms to do similar things. You want to run the fewest number of algorithms for something that happens during every interaction and potentially does thousands of comparisons, right? Your performance is going to get sluggish and it's not going to feel good on mobile phones and all this sort of things. So check Pencilmarks. This is what we're doing. And this, yeah, you see, because we have already calculated the scene cells here. So if I were to recalculate them on a different sort of scene matrix, that wouldn't be fun. Because the scene cells is calculated once and then passed into different checkers here. So I'd have to basically calculate 2 different scene cells matrices, one for all scene cells, including all the other rules, and a different one which only looks at rows, columns, and cages. And in this case, actually, these cells would still be marked because they're in a region. So what they want to basically exclude are anti-king, anti-knight, and cages. I'm trying to think, like, since they're being passed in here, technically you could have a global setting. Hey, Rocket Zero. Since they're being passed in here, technically there could be a global setting that changes these. The problem is it doesn't just change the pencil mark checking, it also changes the digit conflict checking. I don't even know what else is getting affected here. Thanks for stopping by the stream, by the way, Rockret. People like to complain, but they don't like to be part of the solution generally, sadly. Checker, checker. Yeah, so for example, the killer calculator uses it. And of course, you don't want the killer calculator to give you different numbers depending on your difficulty setting, right? You want it just to give, and it's already incorrect too often. But other than that, it looks like I'm not using it too many other places, right? Where are we here? Special select all scene. Yeah, that's my special my secret hotkey. That's not official, so I can mess with that. Which one is this? This is happening in special select all scene, so that's the same one. This is in the checker. So if I go here, right. And here, actually, this is a bad place to demo it. I need a test board with some killer cages. So let me just grab something from the Discord puzzle archive, something with some curvy and large killer cages. Straight killer cages aren't going to help. These don't escape region boundaries. I need juicy killer cages. Oh, I think this one might do. Yeah, and I think I played this recently as well. So here, this cell sees these, right? And if I put a 1 here, yeah. And that's basically the sort of thing that I think Bremster wants to disable. So, and currently, puzzle info contains these cages, cells, rows. So if I remove cages here, so if I just do, and I'm just going to output this quickly to have a comparison. But then if I do delete dot cages, and if I remove the anti-knight, and anti-king checks, everything blows up. Can read properties undefined, reading filter. What? Uh-oh. Does it expect some of these to be there? It does. It does. Oh, yeah, no, I'm an idiot. It doesn't work like that because cages, it doesn't differentiate the type of cages. So rows and columns are also cages. So we need to actually filter these cages specifically. It's always more complicated. No matter how complicated I think it is more complicated yet. And the problem is the cages here have already been converted to cell lists, right? So they don't actually contain any of the meta information. But I think I can retrieve that because I think they get subgroups cages. Yeah. They map. Is this filtered? So if we look at these, we have 44 cages and we have 37 cages here. So they are being filtered somehow. Cages. Get cell groups. Get cell groups. How can they be different? They should be a one-to-one mapping. Cages. Is it because of the caching? Because here these get updated. Because caching there doesn't work, if I recall. And if I do this and do this, it could just be that they already have changed by the time we get to the second line. Current puzzle, puzzle info, 5138, 1706. I'm getting really hungry. I guess that's a good sign. 4437. How are they different? God damn it. Are they... Is it because they were cached at an earlier time and then cages were added? Current puzzle cages 4437. 44 37 00 44 37. Oh, there is some shenanigans happening here. Except in this case, no cell groups should be different. So this is the algorithm that Mark built for splitting cages up when they are disrupted in fog of war scenarios, which is a whole other can of worms. And I was very happy that he managed to implement it as he did. But I'm guessing, because here's no fog, right? So I don't think the groupings should be any different. But apparently they are. Apparently they are. So let's have a look. Length 0. Okay, length 44. So we have 44 cages, but only 37 groups. How? Mark? Enlighten me. How does a regular puzzle how does this algorithm eliminate some of these cages? Is it a Is it making some kind of elimination that there's some cage here that's not necessary somehow? Groups dot push. Exclude types includes. Exclude types. All right. Region and row column. If. Wait a second. So this already excludes non-row call and region cages. If not unique, return cages. If return groups push cells. So this is before cell groups get pushed. If includes. Oh, okay, no. It's the other way around. It doesn't split these cages, so they just pass straight through. All right. All right, this is going to take a while just to dig out what's going on here. no way can I do anything useful here today. So let's have a look at this. We really don't need the warning here. Hmm? One five five six 155. So we're passing cages. So these are all killer cages. Pass through. All right, instead of that, we're just going to put type here. And where else are we adding groups? Here. A little log. Adding group IDX. Type cells. So we're adding groups for cages 0 through 9. Then we're adding cages straight through till 36. And I'm wondering if the last groups aren't getting added somehow. Where's this happening? Wait. Cells. Cells. Cell groups push. Groups push. Ah, okay. So there's a couple more getting pushed here. I guess some of them don't have the right length requirement. Groups. Is there a return elsewhere here? There's a return here. Hide clue. If hide clue return. Console.warn. Hide clue return. IDX. Hide clue. Are we returning from there? Because we have 44 cages, right? So final push doesn't happen. So we're hitting page pass through here. If not unique. Oh, okay. So not in unique cages are skipped as well. Not unique. Okay, so non-unique cages are being ignored. And they're not at the end here. We're missing... All right, we're just gonna output something here. So, cage, IDX type, unique. Unique is true. It's not an excluded type, so we're not returning here. We're not returning here. Maybe we're returning here. I mean, there shouldn't be any fogs, right? Because nothing is fogged. Skip short cage number 37. So if we do this, and we look at one of these skipped cages, So 37 is being skipped. Row 34 to row 3, column 4. Row 3, column 5. Oh, okay, it's the V. So they're being skipped for the checking because they're already covered by the row column. Okay, all right. All right, mystery solved. So, okay, all right. So those are all being skipped. The others are being added, and I don't think anything is actually getting split up. Like there was no adding group or whatever. So I can just undo everything I've done here. Right, I think I can just do it this way. Undo. For that, get rid of that. Okay, so that explains why we have 37 instead of 44. Now, if we want to exclude all of those other cages, right? So the problem, okay, the problem is that after they've been turned to cell groups, they don't one-to-one map anymore to the actual cages. So what we really want to do is we want to pre-filter them and then run them through this again. Okay, this is really expensive, but you know, we can optimize that. All right, that went down a little bit of a rabbit hole there. We don't really need to mess up the syntax here, though. Don't need that. All right. So, if we filter the cages, so let's see. We just want to look at the cage here. I'm gonna just hide this all of this for a sec. It's not helping us. Just making me crazy. So we have the cages here. The original, the OG cages, right? And there's 44 of them. Now, if we want to filter them by box or region, okay, so we basically want to filter them the same way we did it here. Something like that, I guess. So then that would give us only 27 cages. And 27 cages makes sense. Yeah, it's 3 times 9. So we have 9 rows, 9 columns, and 9 regions. And now if we run this through our cell groups algorithm, and obviously we could put this switch at the higher level, or we can, you know, the thing is, the fact that this is not being cached at the moment is already a bit painful to me. Am I looking at the right puzzle here? Yeah. So this gives us, we went from 27 cages to 9 groups. Why do we end up with 9 groups from the 27 cages? Or are we ending up, no, sorry, not 9 groups. We were ending up with 27 cell groups. Okay. So, if we go back to puzzle input cages. Here. Puzzle info cages, we have 37. And now we could reassign these to this. Right, get rid of that. Put a comment there because I'm gonna have to stop soon, and tomorrow this is gonna all seem very crazy to me. Create cell groups on filtered cages. Row, call, box only. All right. So now that takes us from 37 to 27. 37 to 27. Okay. Get rid of that. Get rid of that. This is from mess we did earlier. Okay, this is a whole new different mess. So now, if I put a 1 here and 1's here, it doesn't conflict anymore. So I don't know if that's enough, but I can roll this into something to test with on alpha, for example. In fact, maybe that's exactly what I should do. This is a general good put, adding a default value there as an array so we don't error out on filter. That's generally good. So I can just push that. Yeah, I don't even need to version that. Okay, so we're now looking at only just of these couple of lines here. And ideally, the only changes are here. Filter cages. So, filter cages. Remove all but row / call / box checks. And this should reflect in our scene cells. Yeah, so it doesn't see this anymore. And this will also not see anti-king and anti-knight. Of course, this affects multiple features now. So what I can do now is I'm going to leave it like this. I'm going to deploy this to alpha. And then I can send it over to Bremster to take a look. Oop. So if we add scene cells, so we are on version 0.254 here. This doesn't seem to do the trick. Wait, what? Why was I'm confused. A second ago, I was pretty sure these two were highlighted, but now they're not. All right. So I can put a 2 here, 2 here. Okay. All right, well, I'm going to leave it there for now. I got to get going. Yeah, all these things are more complex than people understand. And the problem with it is that by adding things like that, it makes future development hard. And that's doing this in the past is the reason why this is hard now, right? So adding to it is just going to make this problem bigger and bigger and bigger. And people will understand less and less and less why I can't just do the thing, right? So that's why I'm pretty loath to do these kind of things. And what I really need to do is I need to rethink internal APIs and shit. But that's the problem with that stuff is that's a lot of work where best case scenario, nothing changes. Worst case scenario, a bunch of unknown things break that nobody notices, right? So that's why I'm also very loath to do a lot of this kind of work because nobody wants me to do that work, right? People barely want me to do the work that I'm already doing, let alone doing work that doesn't have a result, right? Just for future promises. So, my income is severely shrunk. So I need to do the things that, the large majority of people need, such as updating the paid app and things like that. So it's hard to justify doing this kind of internal work. I'd love to do it, If my Patreon was 10 times what it is right now, then that's what I would be doing, But that's not the world I live in at the moment. Anyway, on that sad note, thanks for joining me on the stream. Always appreciate the company and the feedback. And take care. Have a good Sunday evening and have a great next week. Bye-bye. Thanks for hanging out on Code Hangouts with Sven.